As she said, my name is David Myers. I'm a senior in the information technology program with a double minor actually in computer science and organizational leadership. I joined the honors program the first semester of my sophomore year, and it's really been a pretty great time. So my project now is, as it says, it's a perishable protection application. I'm in IT and computer science. It's a computer program. Its purpose is to hold a list of perishable items and the storage locations used for them in a person's home. It allows the users to view, edit, and sort this information in multiple ways. And the key feature, the one that first led to this idea, was, of course, that it would alert the user when an item is about to expire. And I also later added functionality that provides recipe suggestions based on available items. So inspiration. I grew up on a farm. My family did lots of preserving vegetables, other farm products, some canning, but we also froze a lot. And this is actually a picture of one of our freezers as it is right now. That's a mix of homegrown and store-bought stuff. These are very large freezers, and it's really easy to put stuff in there and then lose track of it. Forget you have it entirely, or at least forget where it is, and then it goes bad before you remember to use it. So we had some of that happening last year, and this idea occurred to me. And when I first thought of it, it was sort of just, oh, that's a neat idea. But then it occurred to me, one of my honors classes was an H option in Advanced Visual Basics. And it occurred to me that one of the programs we did in that, a database application that tracked information about students at a karate school, actually was quite similar in basic concepts to what I would want to do here. So I began to think, between that and my other courses, maybe I could actually do this. And I initially put it up for an idea for my senior design project. Didn't end up using it there, but it was my favorite of the ideas. So when I came time to do this, I decided I'm going to do this one. So very overview of how it works. It's basically 4 stacked layers of data storage and manipulation to get to the user. The lowest layer, where the data is actually stored, is a database file, a SQL file. SQL stands for Structured Query Language. It's a pretty common language used to define and manipulate the information in database tables. And the database is connected to the main application by what's called a DATASET. That's Visual Basics functionality in most Visual Basics programming. It's sort of an in-memory copy of the database created when the program runs, but it has what's called table adapters, one for each of the tables in the database that actually store the data, and I'll explain that more in a moment. And it helps the user get the data and manipulate it. And then I've created what mid-level or adapter classes. Those are Visual Basics classes, a collection of code, and they work to further refine the data and perform other functions that enable the more seamless user experience. And then finally, of course, there's the user interface itself, what the user actually sees and works with when they're using it. So starting with databases and data tables, a database is just basically a word for an organized collection of data of a particular sort, though. The most important item in a database is the tables. And tables are used to store the information. Generally, one table will store like a list of things that are all of the same type. This is a visual representation of a table from my application that stores all the locations you might store stuff. So you see you got freezers and refrigerators and stuff there. And database, because you can see this is pretty similar to a table you might find in like Excel or something, because you got each row represents a single item, each column represents a particular attribute. But there's one important distinction between a database table, actually, sorry, 2 important distinctions between a database table and most tables you would find in like most other Microsoft programs you might be familiar with. The first is the primary key field. There's a rule with database tables, all the entries have to be unique. And specifically, they need 1 or sometimes 2 or more fields that are defined as the primary key, and the entry in those has to be unique, different from all the others. Now, sometimes you can use properties of the items themselves, like if you were doing a periodic table, each of the items has their own unique atomic number, so that would work. But if you're doing like a customer's database, you might have a lot of John Smiths. So instead, a lot of times you create what's called an ID field. It's auto-incremented. The program generates it automatically. The user usually doesn't even see that field unless it's like part of a customer number or something. But it helps to uniquely identify each item that's entered into the database. And then the other thing that sets them apart is relations between tables. So information that is related in some logical way but stored in separate tables can be linked by these table relations, which are basically a rule that says for every unique value in, say, the item type ID column right here, there has to be a corresponding value in the actual item types tables ID column. And so, for example, between storage locations and items, each item has a storage location, it has a location ID. I go by that ID and I find the corresponding location, so then I have the location information as well. And that works for pretty much all the tables in here are like that. Many items on one table are related to a single item on another table. And items also, of course, have a type. Both type and storage location is related to this, which holds things like frozen, refrigerated, room temperature, etc. Because the item, like frozen strawberries is an example of one item I have, so that has a freezer type association. And of course, the freezers also have that. The two tables that are a little bit unique in mine are the recipe and ingredients table. The recipe, of course, holds the recipes that the user enters. The ingredients table is there only to serve as a link between the recipes table and the rest of the database. It provides a means by which I can say, okay, if I have this item, what can I make with it? I find its type, I find the recipes that go with that type, and then I have the recipes. Okay, so data sets and the table adapters. This is a representation of the data set for my project. And as you can see, it looks fairly similar to the last page. There's an adapter for each table, and the relationships between them are still there. Each of these contains 4 queries, which is a SQL language. It's the SQL statement that manipulates the data in some way. Specifically, they select, insert, update, or delete. And what you're actually seeing there is kind of a summary of the output of the select statements. In the previous ones, you were seeing the list of the columns that were actually in the table. Here, if you look, the items has a lot more columns. And that's because when I select from the items for the user to view, I want them to see all the important information from the storage locations and the item types that go with that particular item. And I'm also having it calculate exactly how many days remain until the item expires. So more about the queries in specifics. Select, that's show me what's in the table. And it starts off with the select keyword, and then you tell it what to select. So I got a list there of everything in the items table, as well as the other things I mentioned from the items type and the storage locations table. So all the information about the items there. The from line, that's saying where do I go to get this information? Of course, it's going to the items table, but it's also going to those other tables. So we use what's called the inner join rule. That means show me values that are combined from these tables. And I inner join items to item types on the basis that the item type ID field is the same in both ones. And then same thing with the storage locations and their location ID. Order by is optional. You can run it without this. But what order by does is it allows me to display them in a certain order. In particular, I chose to display them from the one that's going to expire first to the one that's going to expire last. Insert, this is the one that allows you to add new items to a table. So insert into items, again, we're just looking at the items table, and then a list of the fields in the items table it's inserting into. That's all of them that are specifically in that table. And then values tells it what to insert there. You can put actual values there if you always want to insert a new row that's the same as the previous one for some reason. I'm not sure why you would, but in this case, those symbols indicate that we're looking for user input. So when this runs, it will be expecting to get input from the user and turn that into a new row. Update, kind of similar. Again, you're updating the items table, but in this case, you're changing what's already there. You're changing the values in a currently existing row. So set the description equal to the user provided description and so on down the list of attributes. And this one would affect, if run without the where argument, this would affect the entire table. Every row would change to be like this. The where one tells it which ones do I change. And in this case, you see it's telling it find the ID that equals the ID the user provided. I could, of course, use a different property. For example, if I use the type ID, then I could update all the frozen strawberries at once. And then finally, delete if you want to remove one. Delete from the items table, and again, the where clause tells it don't delete all of them, just delete this specific one. So the mid-level classes, or I sometimes call them the adapter classes. Visual Basics classes, they serve as a link between the dataset's table adapters and the user interface. There's one for each table adapter, just like there's a table adapter for each table. And what they do is they filter information, so they show users only specific information. Each of those table adapters only has one select query. If I wanted to look at the data in a different way, I'd have to add more. But in this case, what I can do is use that one basic select query and then apply filters on it in the adapter class that allow me to, for example, show only a single row or only items of one specific type. They also enable error checking and correction that's not available with the SQL queries. And that's an important concept from the whole field of human-computer interaction. You don't want the bunch of numbers as an error code, or even just the system to not do anything when you click something. You want it to say, why isn't it doing something, or what just went wrong. So I tried everywhere I can. There's an error message that either stops something bad from happening and then tells the user why something just went wrong and how to correct it, or actually prevents the user from making a mistake in the first place. And finally, of course, the user interface. Visual Basics forms and controls. Visual Basics is a Microsoft development tool, so this stuff will look a lot like most Windows forms used to seeing, maybe a little plainer, but similar in many ways. They allow the user to navigate through the information stored in the application and provide the means for the user to manipulate the data. Again, I'm trying to make these as user-friendly as possible. If confusing forms don't do any good. So, and now, sorry that popped up, but I can run as soon as it starts. There we go. So this is what the users, oh dear, it's not showing up. Just a second. I don't know how that happened, but somehow it switched to extend instead of duplicate displays on me. So sorry about that. So this is what they first see. And it's sort of divided into two parts. The upper part is navigation with the menu bar taking you to all the various functions. The lower...
Can it be bigger? There you go. Okay.
Sorry, the controls don't expand very well. The items lower than that, that's sort of an abbreviated list. It doesn't show you all the attributes of each item. It just shows you the important ones, what it's called, where it's stored, and the information related to how long it will last, including the remaining days. And you might notice a couple of those are negative because they've been in there longer than they should have been. So that's the alert feature, the idea I first conceived. Tell the user immediately if something's about to go bad. And then you can add new storage types, storage locations, item types. These three fields are all pretty much the same. You open it up, you get a list of the ones that already exist. And here's the freezer with information about it, its notes, and what storage type it is. And you can edit, and here's an example of an error message. I forgot to click on an item I wanted to edit. But you can select one and edit it. You can then change anything you want in here, including, and this is where those table connections I mentioned come in. In order to make the entry of this data easier for the user, I pull the values from the table listing the type, so they just select the appropriate one from the list. But I don't want to edit that, so you can, of course, cancel. Add new is pretty much the same, except it opens with blank values, because you're not editing one that already exists. Now, the different ones, the important ones, of course, are over here, item types and recipes. First, sorry, not item types, items. First of all, the items. And it still has, of course, the add and edit functionality like the other ones. In case you made a mistake, you need to change the item, or you want to add a new one, obviously. But it also has a couple of other functionalities. And first of all, there's this filter, because if you got a lot of stuff like we do in our freezers, scrolling down through the list by storage date might be a little tedious. But this way, you can choose, okay, I want to see hamburger. And the oldest hamburger immediately shows up on the top. Or select the chopped strawberries. Again, they all show up with none of the other stuff displayed. And then, of course, you can also, if you've eaten an item, of course, it's no longer should be in there, so you can choose to remove the item. And it will show you the data. You can't edit it, but it will ask you if you're sure you want to delete it. You select yes. And then, of course, you can also do this. Find recipe. this shows you the recipes by that type of item. So I clicked on a strawberry entry. Now it shows me all the recipes that can be made using strawberries. If I select one of them and click View Recipe, the recipe form opens. Normally it would open blank, but in this case it opened with that recipe loaded. Now recipes are displayed differently than all the others because they've got a lot of information. You have to write the whole list of instructions down. So just looking at them in a row like that would not be feasible. So instead what you have is a list here, and you can click on whichever one you want to see, and the information changes to reflect that recipe. You want to edit it, just select here, and all this becomes editable. You can save the changes, or of course you could cancel if you want to. And then here is how it knows how to find the recipes. You list the major ingredients, the kind that you're storing in one of these places that go with this thing. So you can of course add an ingredient, and this is going to be a little ridiculous because I only have the 2 types, but let's add some ground hamburger. And of course we don't want that, so just in case you ever make a mistake, or if maybe you change your recipe at some point, you can always remove it. And then finally you can reverse the effect we just saw of going from item to recipe. You can, if you're in the recipe and you want to know, okay, do I have this item that I need to make it, you can check the availability and it will open up the items form with that specific type selected. So basically, I started off as just a don't let the food spoil idea. That's what I begin with. But I eventually grew it into an app that provides both that functionality and the ability as a sort of meal planning helper. Also, it did occur to me as I was building it that you don't have to limit it to food. Anything with a finite shelf life can be stored in here. And I gave the users the option to edit any of the parameters that go into it because I don't necessarily know, I have no idea how many freezers someone's going to have, and I don't even necessarily know what storage types they have. Maybe someone has some kind of humidity controlled storage they use. They can add that. So yeah, that's that. Before we begin taking questions though, I would just like to thank Professor Parker, Professor Michelle Parker, and Professor Matthew Parker, who isn't here. They were my mentor and my external reviewer on this. They were a ton of help, and thank Professor O'Connor. She helped me refine my presentation. And just thank everyone in the honors program. This has been a pretty great 3 years, I guess. Okay.
So where can we get this?
That's not quite ready yet. There's a difference between does work on my computer and does work on other computers. I have begun experimenting with it, but to get it published, and I think I may be able to eventually burn it onto CDs, but at this point I'm more focused on getting my schoolwork done, so.
But you'll keep us posted.
Yeah, I guess so. I don't work that far away, so even after I stop coming here, I guess if I ever finally get it done, I can drop by and say, want some CDs? Okay, so someone else? Okay, yes.
Yeah, I'm not sure if I'm using this correctly. Oh, got it.
Okay, so I was just wondering if this could be adapted and maybe sold for use in restaurants or supermarkets or...
Pretty much as is it could. I'm thinking if you want to go really large scale, you'd probably need to change the user interface a bit. But that being said, that is changeable. Again, every layer is separate from every other layer. You could slap a whole new interface on top of this without necessarily having to change anything else. And a lot of the code is fairly modular. You do the same thing to get the same results from every table. So even if there was a function that I didn't put in here because I didn't feel the need for, that you felt the need for, it probably wouldn't involve very much coding to actually get it in there.
Because it would be interesting. I know I teach French, and I've been discussing with my students the movement in France to eliminate waste in restaurants and grocery stores. It'd be interesting to see if this could be, a very helpful tool in those kinds of movements here in the U.S.
Something like that. I kind of imagine actually that this thing works best with when turnover is lower. If turnover is a lot faster, like you get in a restaurant, supermarket, a full application with this many features may not be what you really need. You might need something that's much just easier to edit and look at real quick. Parker?
Oh boy, you're ready for this question. If you could explain to us a little bit about some of the challenges that you faced going through the process of this development, and just kind of explain what you went through and how you were able to solve some of those.
Actually, I'm kind of glad you asked because you reminded me of something that I wanted to touch on for a moment but forgot to. The reason for the adapter classes, because they're not the only way to do this. You can use what are called data-bound controls and forms where the user interface is directly connected to the table adapters. And that was one of my big challenges because that's where I started this program and I was running into lots of problems. It's not as easy to do error checking, it's not as easy to provide helpful error messages that way. And it does have a few advantages. There's a little less coding, but in the end I decided that that wasn't the way to go with this, that it would be better if I added the classes in the middle and then put the user interface on top of that. Also, another one, I actually started this out. If anyone still has a copy of my old proposal for this, they'll notice it mentioned Microsoft's Access system, which is another database program they use. That was originally how I was going to make the database itself, but it turns out that Access and Visual Basics don't like each other that much. So I switched back to SQL because the Visual Basic editors actually have that built right into them.
Sorry, I actually did have an actual question, and not just excitement over the using this. You mentioned for the recipes that it's something that you have to manually enter. Does it have the capacity moving forward to maybe be connected to there are all these websites, right, that have a lot of recipes or recipe databases. Is it possible, instead of you having to type in the recipes, right, to have it be connected somehow so that it accesses recipes? Especially if the idea is like, oh, what can you make with this thing that's about to expire? You may literally not know, but having kind of this larger size database would be more likely to have ideas for what to do with an about to perish, ingredient than something you may have thought of a month ago that you thought to enter into the program.
Yeah, that's possible. One thing I suppose, one way you could start towards that is to take this basic idea and put a web-based interface on top of it. That would be a start in that direction, but as far as connecting, there's a difference between if I were to build a web-based data site on my own that was exactly like this thing's own internal workings. Connecting to that, while challenging, wouldn't necessarily be too difficult. If you're talking about maybe getting advice from outside sources, that would be a lot harder. You're looking at something that has to basically be able to incorporate search engine-like functionality into it. But I have a lot of old family recipes, so that's what I was thinking of when I initially designed the recipe portion of it.
I have a couple questions just because it seems to me that with what you're trying, which is kind of neat, one of the issues I'm wondering about is data entry, and because that can be rather, well, tedious. For example, entering the recipes, tedious entering objects. Have you put any thought in like speedier, less painful ways, such as perhaps using a phone app to scan barcodes and that sort of information to feed that into your program?
That would be possible. Phone apps is one area that I have not myself studied. I know some of my fellow students have. That wasn't an area I got into. So that's possible. Another thought I had that occurred to me actually just as you were asking that was one simple fix I could do to make it a little more user-friendly would be to add a quantity indicator to the add new under items. Because if you're like got a big strawberry patch pick or green beans or whatever, and you're probably going to be putting a lot of bags in at once. And even if you're buying something store-bought, you may buy like a bunch of pizzas because they're on sale. So you would want to maybe have the option to just check a box and say, I'm adding more than one, input the number, and then it automatically adds that number of those items to the list.
Okay, I have a follow-up just with what you said. One thing I was wondering about the recipes is you mentioned chopped strawberries as perhaps one of your items in the freezer during your presentation. And usually it's not one chopped strawberry I'm going to use in a recipe. It's probably going to be like a cup or something. Have you thought of anything in your in your program for recipes that are not going to use like a full bag of strawberries, but maybe half a cup, whether it'll subtract that amount from an estimated amount in bags?
Not really, because I was working for a situation where the exact amount you're storing at any one time is pretty much unknowable. Again, it was somewhat based off my own experience. When we're storing fresh strawberries, we kind of just guesstimate how much we're going to want to use later, so we put them in various size containers as they come available. So you'd have to sort of look at the list of what you still have and then kind of guess which one would be the best to take out and use for your purposes. Yes?
If you added so if you added extra fields like, quantity, would you then have to use quantity all the time? I kind of thinking based on this, so that if you have bags of different sizes, sometimes you may want to specify how big it is, sometimes you just care that there is a bag in there. Like, would it give you an error message if you didn't fill in every single field for a particular item? Or could you skip, skip something?
A couple of answers to that. I'll give them all. First of all, this thing, if you notice, there's in the description, I have been using pints, quarts, pounds. My intention was that generally the size of a particular stored amount of something that was variable, like a hamburger, strawberries, would be listed in the description. As far as quantity in terms of I put this number of bags in there, of course you could use that on or off. In terms of if you wanted to use an application where you could sometimes input a numeric number that indicated how much was in one container, but you didn't necessarily want to always use that, it could be done. It would just be a little bit messier in terms of, because it is possible to say this field's required or this field's not required. As a matter of fact, pretty much in all these, the notes field isn't required.
Messier from the user interface point of view, or messier from the programmer's point of view?
A little bit from the programmer, a little bit from the user interface, but because obviously you'd have to take both situations into account, and a display that would display a combination of both. In the user's case, they'd have to keep track of whether or not they're supposed to be tracking that particular property for that particular item.
I know the answer to this, but I'm going to ask you so everybody else in this room can get a feel for this. Can you explain to us the coursework that you have done over the last 4 years that played a part in you being able to successfully complete this project?
Okay, well, as I said, I mentioned the initial, maybe I should do this idea came because I realized it was similar to an idea from the Advanced Visual Basics course. It's a second semester course in Visual Basics Programming, which I had actually taken as an honors option. But as for the first course I took that led to this, I'd say it would be SQL Server Management. I took that, I think, back in my freshman year, actually. And then there were a couple of others. I, of course, took the first semester of Visual Basics Programming. There were a few concepts from that still made it into this. And then I mentioned Human-Computer Interaction. That's another course which focuses on, what rules are good are a good practice to make this usable, to make it user-friendly. And then I suppose a little bit from IT project management. Not quite so much that one, but it was one of the honors courses I took, and I actually, for the honors part of it, I kind of did a simulation management of a project, so I got a few ideas from there. In fact, that course, I believe, included one part where we worked a little bit on how databases should be structured to make the information most useful and user-friendly.
David, I'm curious whether the expiration dates are something that the user inputs, or is that in a table that automatically generates?
Well, the user has to input pretty much everything they want to add to it. But how they're generated is that the item type has an expiration date. Like I looked it up, frozen strawberries, if they're chopped up and then frozen, best time to use them is about 120 days after they were put in the freezer. So that info value goes in there. Then when you actually store an actual instance of the item, you add the date you stored it on. And then this program takes those two values, date stored and lifespan, and calculates your actual expiration date. It specifically tells you how many days are left or how many days have already passed since it.
How long did it take to create this app for you?
Counting or not counting all the stuff I started and then had to throw out and start over again.
Yeah.
Everything, probably about a week. That is compressing the time I wasn't working on it out of the picture. I'm not 100% sure of that answer, but that feels about right. Because once I got through the initial hurdles of the database part, because getting the database linked to the data set properly was the trickiest part of this whole thing. Once I got through that, the rest of it was actually relatively simple coding, particularly the user interface. Visual Basics is a system designed for creating visual applications. So